We got a square ABCD that represent a cube and stand on the base AM. Let DM represent the ladder such that the length of the ladder outside the cube is exactly equal to 1 unit. Further, the cube is of side 1 unit each, or square is of side 1 unit each. What do you think is the distance between base of the cube and the base of the ladder? What do you think the minimum distance between base of the cube and base of the ladder? So we want to find BM. We are given EM equal to 1 unit. AB, BC, CD, DA are all equal to 1 unit. Let's start it. Now you see that cube is having property that its opposite sides are parallel. So CD is parallel to AB, or AB is parallel to DC. Once two sides are parallel, we know that alternate interior angles are equal, or Z-shaped angles are equal. So this angle got to be equal to this angle. So both must represent, we say, let's call it theta. Further, we notice that these two angles, these are vertically opposite angles, they are also equal. So triangle ECD is similar to triangle EBM because all the three angles are equal. This one being 90 degree each. Now we can apply property of similar triangle to say that these sides are proportional, or we can use tan theta as well. So we prefer tan theta. Next, if we know EB, then we know X. So we want to find EB. Let EB be equal to A unit. Since triangle EBM is a right angle triangle, we can apply Pythagoras theorem, and we know the hypotenuse, and if we know one of the side, then we can find other side. So let's try to determine A. Now in triangle EBM, it's a right angle triangle. Tan theta equal to perpendicular by base, or opposite side by adjacent side, A by X. Also in triangle ECD, tan theta equal to opposite side by base, or perpendicular by base, or opposite side by adjacent side. Oh, we don't know opposite side, but we know that the side of a square is of 1 unit, and if we regard this EB to be A, then CE must be equal to 1 minus A. So in triangle ECD, further CD must be equal to 1 unit because the square is having side all equal to 1 unit. Therefore in triangle ECD, tan theta equal to opposite side by base, opposite side by adjacent side. So 1 minus A by 1. 1 minus A by 1. Let's combine those two equations. We write this one as equation 1. This one is equation 2. Combining equation 1 and 2. By equation 1, tan theta equal to A by X. By equation 2, tan theta equal to 1 minus A. So as we said earlier, we want to solve for A. Oh, we won't be able to solve for A, but maybe we can express A in term of X. So we multiply by X throughout to obtain, or cross multiply it. 1 into A is A, 1 into X is X, and minus AX. Can we solve for A? Of course not, but we can express A in term of X. So we take AX to the left hand side to obtain A plus AX equal to X. And so from there we take A common, and then we conclude that A equal to X by 1 plus X. Once again, A equal to X by 1 plus X. We just take 1 plus X to the right hand side. So we are not able to determine A, but we could express A in terms of X, and it turns out to be X by 1 plus X. Now, we see that we can apply Pythagoras theorem. Even though we are not able to compute A, we see that all the quantity that we have is just X. All the unknown variable is X. So we might be able to solve it. We see that triangle EBM is a right angle triangle, angle B equal to 90 degrees. So 1 is the length of the hypotenuse, and one of the side is X by 1 plus X, other side is of measure X. Therefore, we apply Pythagoras theorem to EBM to conclude that hypotenuse square, the longest side square, is 1 square, hypotenuse square equal to perpendicular square. So x by 1 plus x whole thing square, x by 1 plus x whole thing square plus base square is x square. So we have reduced the given problem to algebraic problem and we need to determine the value of x. Let's multiply by 1 plus x square throughout to obtain. So we multiply equation 3 by 1 plus x whole thing square. We multiply equation 3 by 1 plus x whole thing square. We multiply equation 3 by 1 plus x whole thing square. These two terms get cancelled. So we obtain polynomial equal to polynomial. So we can write this as x square plus x square into 1 plus x whole thing square equal to 1 plus x whole thing square. The equation doesn't appear easy to solve, but you see that we have x square and 1 plus x whole thing square. Just maybe we will be able to solve it by letting 1 plus x equal to t. So now we assume that 1 plus x equal to t. So x equal to, if we take 1 to the other side, t minus 1. So this equation can be written as t minus 1 whole thing square plus t minus 1 whole thing square into t square equal to t square. Okay. Now we have t minus 1 whole thing square. So we know the formula for t minus 1 whole thing square. We know that a minus b whole thing square equal to a square minus 2ab plus b square. A minus b whole thing square is simply equal to a square minus 2ab plus b square. Let's apply that. So t minus 1 whole thing square is simply t square minus 2 into t into 1 plus 1 square. Same thing here. T minus 1 whole thing square is t square minus 2 into t plus 1. Into t square we copy as it is, equal to t square we copy as it is. Now let's do some simplification. So we obtain t square minus 2t plus 1 plus t to the power 4 minus 2t cube plus t square equal to t square. Somehow we want to factorize the left hand side as well as right hand side, or maybe we want to solve somehow. Observe that t to the power 4 plus t square plus 1. That can be written as t to the power 4 plus 2 times t square into 1 plus 1 square. We are left out with minus 2 into t minus 2 into t cube equal to t square. Okay, that gives us, that will make our work easier. Let's see how. Now t to the power 4 plus 2 into t square plus 1 into 1 square is simply t square plus 1 whole thing square. Now if I take minus 2t common, then again I'll get t square plus 1. Oh, if you notice that once again it is of the type a square plus 2 into a into b. So I need b square. Oh, but I don't have b square to make it a perfect square. But see, I can add b square both sides. So plus t square equal to t square plus t square. So when we add t square, left hand side is a perfect square, right hand side is root 2 into t whole thing square. Oh, perfect square equal to perfect square. We can say something like that. Can we? Here, let's see. So this is a square minus 2 into a into b plus b square. That is a minus b whole thing square equal to root 2 into t whole thing square. Yes, perfect square equal to perfect square. Now, we know that if a square equal to b square, then we can safely say that a must be equal to plus or minus b. Now we have same thing here, a square equal to b square. So we can conclude that t square plus 1 minus t equal to plus minus root 2 times t. But you see that we have assumed t to be x plus 1, did we? Let's see. We have assumed t to be x plus 1, correct, where x represent the length. So x is positive. We don't have negative length, or we don't consider negative length. So if we don't consider t to be negative, the right hand side you can see it to be positive. So sorry, left hand side we can see it to be positive, t square plus 1, yes, minus t, definitely positive. And right hand side is also positive except for this negative sign. So we conclude that t square plus 1 minus t equal to root 2t, since length cannot be negative, since t equal to x plus 1 is positive. Once again, t equal to x plus 1 is positive. It's not even 0. Okay, now can we solve this kind of equation? Of course, yes. T square plus 1 minus root 2, t square minus 1 minus root 2 times t, minus 1 minus root 2 times t plus 1 equal to 0. That's a quadratic equation. It's a quadratic equation. Standard type is given by a into t square plus b into t plus c equal to 0. Roots are given by t equal to minus b plus minus root over b square minus 4 into a into c divided by 2a. b equal to minus 1 minus root 2. So minus of minus 1 minus root 2 plus minus root over b square minus 1 minus root 2 whole thing square minus 4 into a. A is 1, c is also 1 divided by 2a. So t equal to negative of negative is positive. So 1 plus root 2 plus minus root over root 2 square is 2. 1 square is 1 plus 2 root 2 minus 4 divided by 2. So t equal to 1 plus root 2 plus minus square root of 2 plus 1 is 3. So 2 root 2 minus 1 by 2. Now t equal to x plus 1, we want to find the value of x. So x plus 1 equal to 1 plus root 2 by 2 plus minus square root of 2 root 2 minus 1 by 2. Take 1 to the right hand side to say x equal to root 2 minus 1. Yes, root 2 minus 2. Yes, minus 2 plus 1. Yes, root 2 minus 1 by 2 plus minus square root of 2 root 2 minus 1 by 2. Once again, 2 root 2 is 1.4. 1.4 into 2 is 2.8. 2.8 minus 1 is 1.8. Square root of 1.8 is definitely greater than 1. But root 2 minus 1 is 1.4 minus 1 is 0.4 roughly. So you can see that this quantity, if I take negative sign, then x will again turn out to be negative, but we want x to be positive. So the only value of x is root 2 minus 1 plus square root of 2 root 2 minus 1 divided by 2. That's the length. You can write the answer as it is, x equal to root 2 minus 1 plus square root of 2 root 2 minus 1 whole thing divided by 2 units. Or you can determine approximate value 0.883 units, but approximately.